So we have a couple word problems that go along with these systems of equations. I'll go through the first one. It says a shoe company invests $300,000 in an equipment to produce a new line of athletic footwear. Each pair of new shoes costs $5 to produce and is sold for $60. How many pairs of shoes must be sold before the business breaks even? We're going to try to come up with a cost equation and a revenue equation. If we're looking for break even means cost equals revenue. You have the same amount of money coming in for revenue as you have going out for cost. So the cost is $300,000 one time plus $5 every time you make a pair of shoes. The revenue is you have $60 coming in every time you sell a pair of shoes. Okay. So what I'm going to do is take this equation and set it equal to this equation. And then I'll solve. I'm going to subtract 5x from both sides. Divide both sides by 55. And it's about 5,454 pairs of shoes. The last example is having to do with travel, and you have a 2,000-mile flying distance between Massachusetts and Utah. It takes you 4 hours and 24 minutes to get there and 4 hours to come back. Often you have different times depending on the wind and if it's at your back or if it's in your face. So on the way there, it was obviously in our face because it took us a longer time to get there. On the way back, it was at our back and pushed us because it took us shorter. So I'm going to go ahead and define variables. R1 is going to be my plane speed. That would be the plane speed if there was absolutely no wind. R2 is going to be the wind speed. So when we have the wind at our back, with the wind, we'll add them together because we go faster. When we have the wind in our face, we'll subtract them, I'll call that against wind, because we're going slower. Okay? So when we go, when we have these types of things, the distance, the time, the rate, we want an equation that will relate them all to each other, and one of those equations we can use is distance equals rate times time. This is a standard equation that will relate these three things whenever you have them all in one equation. So I do have on my trip there a distance of 2,000. On my trip there I was going against the wind, so that's my rate, and my time is 4 hours and 24 minutes. 24 minutes, 24 divided by 60 is 0.4, so it's 4.4 hours. On the way back, my distance is still 2,000, but my rate this time was with the wind because I was going faster, and it took me 4 hours. Those are my two equations. What I'm going to do is simplify them both by, like the bottom, I'm going to divide both sides by 4. Run out of room. My bottom equation, if I divide both sides by 4, can reduce to this. My top equation, if I divide both sides by 4.4, I would get 454.54. So there are two equations that I have for my two unknowns. And I'm going to solve this with elimination, which means add them together. My R2's cancel. 2 R sub 1, 954.54. I'll divide both sides by 2. I end up getting R1 is 477.27 miles per hour. That's the speed of my plane. And then my equation here said that the two have to add up to 500. So take 500 and subtract that number. And my second rate is 22.72. That's my wind speed.